Hi everyone. In today's lab, we did Lewis structure on VS EPR lab, where we did not use the visual stimulation, and we practically did the lab like this. So why do we learn how to draw Lewis structure and VS EPR theory? Reason is that reason to learning Lewis structure is to predict the number and type of bonds that may be formed around an atom. Lewis structure helps to make prediction about the geometry of a molecule. Lewis dot structure are key concept in understanding how atoms bond. I am basically a big fan of the dot structure. It's really helpful. Okay, so in the VSEPR aspect, the forming of VSEPR is valence shell electron pair repulsion. The theory is used to predict the arrangement of electron pairs around central atoms and molecules, especially simple and symmetric molecules. A central atom is defined as an atom which is compounded to two or more types of atom. Let's take hydrogen fluorine as an example. This I is the central atom is connected to all these other molecules. And then terminal atom is bonded only to one other atom. So for the valence electron, I believe the first step. I believe the first step is to find the valence electron, which I found carbon is 4 plus 2 because I'm doing the carbon C2H2 Br2. So 4 2 times 2 plus 1, that's hydrogen 2. So equals altogether gives a total of 24 valence electron. So right here, I've written how I'm going to put the diagram. You could either do it like this, or you could do it where it says the central, then you put the hydrogen to one attached to one C and the bromine attached to the other C. But I prefer to do it like this, I'll let it have a mixture of the three. So now I'm going to use the octet rule to distribute the ions. So yeah, I've distributed the 24 ions equally among them, and this is what you call a 1,2-dibromethane. I basically got out all my um elements knowledge, and I read some and got it to make this. So we're gonna find the rest. We're gonna do the rest. Yes. So since it's a dibromethane, it will be non-polar because one out of it has net diploid, so it's gonna be non-polar. The molecular geometry is trigonoplanar. The great thing about Lewis structure is that it's not compulsory. It's in a set of structure. You could put it any way you have. So far, you have the valence, you have the ions correct, and the the numbers correct. It has 4 bonding pair and 2 lone pair because it's 24. That's how you know the pair. So it has 4 bonding pair and 2 lone pair, and then the geometry will be square planar. The bond angle is 180 degrees as is a trigonoplanar when you look into the molecule. Well, if you check the textbook, that's how you just know. Well, and this is how it comes out. I'm sorry I couldn't show you how I was doing it basically, but I'm a terrible teacher, I know that. But this is how it comes out. It has 24 electrons. You do this in the electron group and the molecular geometry are both trigonoplanar, and it's a 180 degree, and that's about it. And this is how the rest looks like. There are certain times where the electron group and the molecular, just take the H2 for an example. The electron group geometry is tetrahedra, and then the molecular group is bent. And then there is this one, and it actually looked pretty nice. I'm kind of proud of myself. It looks so artistic, creative, and beautiful from a science student. That's something. And then this, well, I want to say this lab was easy, to be honest, because I'm kind of not, well, it wasn't that easy. It took me a whole day to finish and complete this whole process, but it came out nice. Well, it didn't take me all day as an all day. I had other things to do, but well, that's about it for this lab. I hope you had fun and you enjoyed the lab. I know I didn't really explain, but hopefully you could bear with me and thank you.